Good morning, my dear students. Welcome to the science classroom. And we are dealing with chapter 12, which is electricity. And in our last class, what we studied about resistors in parallel. But I'm sure you didn't understand it properly. Some doubts may occur. So once again, I'm going to activity 12.6. And let us see what is there in 12.6 activity. What it says: make a parallel combination XY of three resistors having resistance R1, R2 and R3 respectively. Connect it with a battery. A plug key and an ammeter are shown in the figure 12.10. Also connect a voltmeter in parallel with the combination of resistors. Okay, let us draw that diagram. A circuit. So, positive terminal of the battery, negative terminal of the battery, and current I flows in this direction. And here X is there. So I am marking some points L and M. In between L and M, I connected resistor 1, and point P and Q, I connected resistor R2, and between S and T, I connected resistor R3. The circuit is okay. So one more thing is there. We have to connect one voltmeter V in parallel. So it is clear now. Positive side and negative side. Current flows in this direction. And what is next? Plug the switch key and plug the key and note the ammeter reading. We want to note the ammeter reading. What is in ammeter? Current I. Okay. So let the current is equal to current be I. And also we want to check the voltmeter reading. What is in voltmeter? Potential difference. So let the potential difference be V. Okay. Till there we completed. So what is next step? We can understand that the voltmeter is connected here. So we will get the potential difference across the circuit, the whole circuit in this voltmeter. We will get the potential difference across the whole circuit in this voltmeter. So it is possible, and it is in a parallel circuit, the potential difference across respective, that means individual resistors also will be same. Okay, that means the potential difference V across the full circuit will be V, and also the individual resistors also will be V. Okay, we are having some option to check. Okay, let us go to the next part. Take out the plug from the key. Remove the ammeter and voltmeter. We are taking the plug from the key, and we are removing the voltmeter and the ammeter. we are removing the voltmeter and the ammeter. So the circuit here we are closing, and here I am connecting the voltmeter, positive side of the voltmeter and negative side, and here I am connecting the ammeter, positive side and negative side, and I am owning the plug key, and I am noting the voltmeter reading across R1, voltmeter reading across R1, that is also V, and ammeter reading I am checking, that is across R1 is equal to I1. It have changed. Then I am removing the plug key and I am connecting the voltmeter across the point P and the point Q, and I am removing the ammeter from here and I am connecting ammeter between Q and Y, ammeter across Q and Y, and I am connecting here and on the switch key, and I am taking the voltmeter reading R2 is equal to the same only V, and ammeter reading it have changed that across R2, that is I2. Similarly, I am connecting the voltmeter across, I am offing the plug key and I am connecting the voltmeter and ammeter. I am changing the position of voltmeter and ammeter. Voltmeter I am connecting here and ammeter I am connecting here, and I am checking the current and potential difference, and voltmeter reading R3 is the same, and ammeter reading across R3 is I3. It is different. Okay. From this, what we can understand? We can understand the potential difference V. The potential difference V across the system and across the full circuit, and individual resistors are same. Okay. And in the case of current, what we will observe? In the case of current, that is changing I1, I2, I3, and it is different from I. Okay. So we can observe that the total sum of current, that is total current in the circuit, is the sum of separate current through each resistors. That is, if we are writing the total sum of current, that is I, in the circuit, is equal to the sum of respective or individual plus I2 plus I3. We will get this from R1, this from R2, and this from R3, and we have taken it as equation number 1. And we are taking RP as the resistance, total resistance of the circuit. We are taking RP as the equivalent resistance or total resistance of the parallel combination of resistors. Okay, parallel combination of resistors. By applying Ohm's law to the parallel combination of resistors, we have I is equal to V by R. We are applying Ohm's law. We will get I is equal to V by R. Applying Ohm's law, we are having V by R, and in the case of parallel, we are having I is equal to V by RP. We will get I is equal to V by RP. And Next we are going to apply Ohm's law to the resistors separately. Okay. On applying Ohm's law to the resistors separately, we will get I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. So it's equation 2. So equation 3. And from equation 1 and 3 we are having we'll get V by Rp is equal to V by R1 plus V by R2 plus V by R3. We'll get this a new equation, and or we will get this both side V is constant. Okay, V is same. So from both sides we are cancelling V, and we will get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And this one is using for finding the values. This is used to find the resistance in parallel. Okay. So let us go through one example. Okay. And yesterday the doubt was here, I think. We are cancelling, the thing we are doing is we are cancelling on both sides. On cancelling both sides, we will get the equation as like this. And next we are going to deal with one problem. Example 12.8. After doing this, you will understand more. .8. What is the question? In the circuit diagram given in 12.10, suppose the resistors R1, R2 and R3 have the values of 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to the battery 12 volts. Calculate the current through each resistor, the total current in the circuit, and the total circuit resistance. Okay, so let us draw the circuit. The same circuit. And what is given in the question, that is, it is of 12 watts, it is of 5 ohm and 10 ohm and 30 ohm. Current flows in this direction. So, what is given? This is a circuit. In this, R1 is 5 ohm, 10 ohm. This R2 is 10 ohm, and R3 is 30 ohm. So, let us do the solution. solution, what we have? We are having the values for R1 is equal to 5 ohm, R2 is equal to 10 ohm, and R3 is equal to 30 ohm. And what is the more potential difference of the battery? Potential difference of the battery is equal to V, that is 12 volt. Done. This 12 volt is the potential difference across all the resistors individually. Then we studied in our activity that the voltage is in the circuit full circuit is V, and also if we are taking individually also it is V. Therefore, to calculate the current, what we have to do? We have to apply Ohm's law. We use Ohm's law. So, the current I1 through R1 is equal to V by R1. Therefore, I1 is equal to 12V by 5. That is 2.4 ampere. And I2 through R2 is equal to V by R2. So I2 is equal to 12 volt by 10. That is 1.2 ampere. Is it clear? Is it clear? And what about I3? I3 is equal to V by R3 is equal to 12 volt by R3 is 30. So we will get 0.4 ampere. And current I is equal to the total current. I is equal to I1 plus I2 plus I3. That is I1 2.4 plus I2 1.2 plus 0.4. We will get 4 ampere. The current is 4 ampere. Current is 4 ampere. And from this we can understand that potential difference is the same across the circuit, and individually also if we are taking the potential difference it is same, but the current here I1 is different, I2 is different, and I3 is different, and to find the current I we have to add all this and we got the current I. And what is total resistance R? In the case of parallel, we are having the resistance are RP. Okay. RP is equal to V by R1. Sorry. So we are having V by Rp is equal to V by R1 plus V by R2 plus V by R3, and in our derivation we have find that both side it is cancelled. What is cancelled? Potential difference is cancelled. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So it is equal to 1 by R1. 1 by R1 is 5 and plus 1 by R2 is 1 by 10 and 1 by R3 is 30. So we will get it is equal to, taking the LCM, we will get it is equal to 1 by 3 and the resistance is 3 ohm. Okay, the resistance across the conductor is 3 ohm. Rp is equal to 3 ohm. And this is all we have for the day. I think you understand the resistors in parallel. Okay, in the case of resistors in parallel, potential difference across the circuit is the same, and also the potential difference across the circuit and also individual resistors are same, and in the case of current it differs. And to find resistors we are having this formula, and we have applied that and we got the answer. And thank you so much. Watch the video and clarify that yesterday we have some problems in the end, and today I have done the activity once again for you and one problem, and study well and achieve good marks. Thank you.